Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we're going to be deriving a moment generating function, and then we're going to use that moment generating function to calculate the expected value. Now before we get started, make sure to subscribe to the channel for notifications on more math tutorials. Alright, now let's take a look at this example. In our example, we're given the exponential distribution f of x equals 3e raised to negative 3x for x greater than or equal to 0. And we're asked to 1. Find the moment generating function. 2. Use the moment generating function to find the expected value of e raised to a half times x. And 3. Without using the moment generating function, find that same expected value. So let's jump right into this. The first thing that we were asked to do is to find the moment generating function. So let's review its formula. It says the moment generating function equals the expected value of e raised to t times x, and that equals the integral from 0 to infinity of e raised to t times x times the function that we were given, dx. So to find the moment generating function, we're going to take the integral from 0 to infinity of e raised to t times x times the function we were given in our example, that's 3e raised to negative 3x dx. Now I'll move the constant to the outside of the integral. And then combine exponents under one factor of e. Now at this point, I'm going to utilize u substitution. So that'll be 3 times the integral from 0 to infinity of e raised to u. And u represents everything that was in our exponent, so that's tx minus 3x. The derivative of this is t minus 3 dx. And then I want to get dx by itself so that we can integrate with respect to u. So I'll divide t minus 3 from both sides to end up with 1 over t minus 3 du, which equals dx. So now plugging back into our integral, we'll have 3 times the integral from 0 to infinity of e raised to u times 1 over t minus 3 du. Because we're integrating with respect to u, this 1 over t minus 3 piece is a constant, basically. So we'll move it to the outside of the integral. And now we'll go ahead and evaluate the integral. We have our constant, 3 over t minus 3, times the integral of e raised to u, which just equals e raised to u. And this is from 0 to infinity. At this point, we'll need to plug back in for u. And when we plug in our bounds, we end up with 3 over t minus 3. So this is our moment generating function. Now moving on to part 2 of our example, we're asked to use the moment generating function to find the expected value of e raised to a half times x. So I'm going to put the moment generating function that we just found off to the side. Now let's bring our attention back to the moment generating function formula. It says the moment generating function, notated m sub x of t, equals the expectation of e raised to t times x. Now keep in mind, we're being asked to find the expectation of e raised to a half times x. So we see here that t equals a half. So solving this, we have the expectation of e raised to a half times x equals the moment generating function at a half. And at this point, we'll plug a half into the moment generating function for t. So we have 3 over a half minus 3. And this equals 6 over 5. Now let's move on to the last part of our example. It says without using the moment generating function, find the expected value of e raised to a half times x. Now, because we're not using the moment generating function, this will be a straightforward evaluation of an integral. We'll still be using this formula just without this piece. So we've got the integral from 0 to infinity of e raised to a half times x times the function that we were originally given, that was 3e raised to negative 3x dx. We'll move the constant 3 to the outside of the integral. and then combine exponents. And then let's do some u substitution. So we've got 3 times the integral from 0 to infinity of e raised to u. And here u equals negative 5 over 2x. The derivative of this is, of course, negative 5 over 2 dx. And then, of course, we'll solve for dx, which equals negative 2 over 5 du. So now plugging in for dx, we have negative 2 over 5 du. Negative 2 over 5 is a constant, so I'll move it to the outside of the integral. In solving the integral, we have the constant negative 6 over 5 times the integral of e raised to u, which is just e raised to u, from 0 to infinity. We'll plug back in for u. And then when we plug in our bounds, we end up with 6 over 5. So we see that we got 6 over 5 with and without using the moment generating function. And there you have it. We found our moment generating function. We used the moment generating function to find our expected value. And then we found our expected value not using the moment generating function. If this video was helpful for you, give it a thumbs up. Like the video, drop a comment down below, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.